Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn, friends, we are going to continue our second part where we are going to configure our Raspberry Pi 4 Raspberry Bullseye as a message publisher with the help of mqtt, and esp8266 micropython will become our message subscriber. Okay, so before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, in last session we configure our ESP8266, CP210, also CS340, and then we configure or we install a MicroPython on our both CP210 and CS340. Okay, so we have now MicroPython installed on our ESP8266 model. So in today's session, as I told you, we are going to install, or we are going to basically configure our Raspberry Pi 4 as a message publisher, and then ESP8266 as a message subscriber. Okay, so let's get started. Simply, first we want to clone the repository. So repository name is mqtt. Okay, go to the code, copy link. I will mention the link inside the description box. Open terminal and simply run the command sudo git clone and paste link and just hit enter. It will clone the repository. Okay, so we have now a repository here, mqtt. Clear the screen. Now simply we want to change the owner. So sudo, because by default if you run the command ls-la, by default the repository belongs as a root, as you can see. So we need to change the owner. We want to change the owner as a pi. Okay, so simply for that we are going to run the command sudo chown space hyphen capital R, then pi and umqtt. This is what our repository name. Okay, so we have now successfully changed the owner for our repository. Now what we want to do, we want to simply install the package. Okay, so sudo pip3 install paho hyphen mqtt, paho hyphen mqtt. This is what the package. So simply hit enter, and as you can see, the paho mqtt is already satisfied, means I have already installed the paho mqtt. So you need to simply run the command sudo pip3 install paho mqtt, and it will install the paho mqtt on our Raspberry OS Bullseye 64-bit version. That's it. You can follow same steps for the Raspberry Buster legacy version, same steps. Okay, so now what we want to do, simply we are going to open our Tony editor, and then we need to open the files which we have just cloned. So go to the file, click on open, and the folder which we just cloned, which is the umqtt, and inside that we have off.py, on.py, and this sub.py is basically, this is the Python file for our MicroPython, means this file we are going to open on our ESP8266. So we don't want to open the sub.py on our Raspberry Pi 4. We only need on.py and off.py. So simply on.py. Okay, so this is what our on.py, and the another file which is the off.py. So go to the open again, and off.py, click on OK. That's it. So now we have on.py Python script and off.py Python script. So import paho.mqtt.client, the paho mqtt package which we just installed. So paho.mqtt.client as mqtt, then import time, then this is what function def on, the function name is on, then mqtt broker, this is what our online mqtt broker server. Remember one thing, we are going to send the message basically with the help of internet, so we need here internet. So this is what our online server broker.emqx.io. Remember one thing here, this is the free server, the server which you cannot use for the production. This is the server for only practice basis. Okay, so broker.emqx.io, this is the online server, then client mqtt.client, because we use here, as you can see, the paho.mqtt client as mqtt, so we are going to use mqtt.client, and this is just a client name. You can mention here any name. Okay, let me just change the name then you will get a better idea. Let's make it freedom tech YT. You can mention any name, so I am going to change the name freedom tech YT. Okay, so as I told you, you can mention any name. Okay, then client.connect, we are going to use the client variable because this client is mqtt.client. Okay, so client.connect mqtt broker. This mqtt broker is what? MQTT broker is the variable. This variable is basically represent our server. So for that, client.connect, we are going to connect with our server. So MQTT broker is the variable we need to pass here. Then client.publish test2. Test2 is basically topic, the topic which we want to publish, and then our esp8266 will subscribe with this test2 message, not message, topic. Okay, this test2 is a topic, okay, which basically our esp8266 will subscribe. Okay, so test2 is the topic. Then this is how we are going to send the message. So message is what? Message is LED on. So LED on, we want to send the message on our esp8266 micropython. We want to send the message LED on. Then same script for off.py, same script, and simply we are going to send the message LED off. Okay, also here we want to change the name, so you can mention any name as I told you. Let's say freedom tech YT. Okay, so save the code. Here also save the code. So we are ready with our Raspberry Pi for Raspbian OS Bullseye site. Now we want to simply move on our Windows machine. Okay, so I am going to minimize the VNC server, and this is what our Windows 10 machine. Okay, suppose if you work with the Windows 11, same steps for the Windows 11 also. Okay, so now here also we want to download our mqtt repository as a zip. Okay, so simply go to the code and download zip, and as you can see, mqtt-main.zip, this is what our repository. Simply click on here and it will open the folder where we save our mqtt-main zip file. As you can see, this is what our zip file. Right click, then click on extract all, click on extract, and as you can see, we have now our extracted folder mqtt-m, and inside that, as I told you, we are going to use the sub.py on our esp8266. So now we have our file. Simply close all these things, and I am going to open the Thony editor, and this is what our last session file. As you can see, the network.py. If you follow the old one video, then you will have also the same name file, the network.py. Okay, so I have connect esp8266 CP210 with my router. Okay, of course, if you have the CS340, then same steps, connect the esp8266 CS340 with the router. Okay, I have already created the video how to do all these things. Okay, so simply go to the file, click on open. Then because we have the file right now in our computer, so click on this computer, and as you can see, mqtt-main, this is what our clone repository, and we need here a sub.py. Click on open. That's it. So this is what our sub.py. Okay, so we have now our Python file ready. Now simply we need to install here a package which is the mqtt. Okay, so go to the tools, click on manage packages, and as you can see, I have already installed the mqtt. How to install? Simply we need to search for mqtt and click on search on PyPy, and this is what the package. As you can see, the micropython -umqtt.simple. Click on here. Okay, and just click on install. As you can see, it's installing. And that's it. We have now mqtt installed. So we are ready. Simply what we want to do, we want to save the sub.py inside our esp8266. So what we are going to do, we are going to simply go here, file, click on save as, and of course micropython device, and we are going to mention the name. Let's say yt sub.py. ytsub.py, because we want to change the name ytsub.py, and click on OK. Now as you can see, the file name is changed. Now we successfully save our file inside our micropython device. Okay, so we have here a umqtt.simple. This is what the module which we just installed. So from umqtt.simple import mqtt client. Okay, then from machine import pin. Okay, so LED is equal to pin number 16. This is what the esp8266 onboard LED pin. Okay, so LED is equal to pin 16 pin dot out, and this is what the message function. Okay, so def message A and B, this is what the object, data like this way. Okay, str b utf-8 format, and print data means when we send a message from our Raspberry Pi 4, it will show the message. What message basically we send from our Raspberry Pi 4 to esp8266 micropython. Then if the message like this way, LED on in data, okay, in data, then LED dot value becomes 0 and our onboard esp8266 LED will be on. If the LED off in data, okay, then LED dot value 1 means the onboard LED will be off. So this data is basically here. As you can see, we mention here data. So this data variable is basically our message. Okay. Then this is what the client function. So as you can see, same server which we use for our Raspberry Pi 4, same server broker.emqx.io. If I open the VNC, as you can see, on Raspberry Pi 4 broker.emqx.io. Okay, and the message, as you can see in on.py, the message is what? LED is capital, then space and on. And on our esp8266, as you can see, I have mentioned here the LED, if the message is LED on, the value will become 0 and esp8266 onboard LED will be on. So same things, LED dot off. If I go again on our Raspberry Pi 4 machine, off.py, as you can see. So as you can see, this is for the LED off message on our esp8266. As you can see, if the LED off, the value will become 1. Okay. So def client server broker.emqx.io, then C is equal to mqtt client. Okay, as you can see, we have mentioned here mqtt client. From umqtt.simple import mqtt client. Okay, so same mqtt client we need to mention here, as you can see. Then this is what the name, as we mentioned here on our Raspberry Pi 4, as we mentioned Freedom Tech YT. Okay, so there is no need to mention a same name on our esp8266. As you can see, we have mentioned here a Freedom Tech YT. On esp8266 we change the name, we mention umqtt client. There is no need to mention a same name. Okay, then the server, so server is what? Server is this variable. Okay, server is basically our broker.emqx.io. Then c.set callback, this is how we are going to call back our message. So this msg is basically our function. This msg is basically our message function which we want to call here. Okay, so for that I have mentioned the msg. As you can see, the msg, this is what our function basically. Okay, so c.set callback, this is how we are going to call our message. Then c.connect, basically we are going to connect with our client. Okay, so then subscribe, as you can see, the test2 is the topic. So c.subscribe, we are going to subscribe with our topic, means our Raspberry Pi 4 as a publisher. So which topic basically we mention here? As you can see here, we mention a test2. This is what our topic. You can change anything. Let's change it. Let's say Freedom Tech mqtt. Okay, so I have changed the topic. Okay, so same on.py, Freedom Tech I think Freedom Tech mqtt. Okay, Freedom Tech mqtt. Okay, just save it. Just a minute. Save it. That's it. So we have saved all these things. So topic is now Freedom Tech mqtt. So on esp8266 also, for our knowing purpose, I have changed the topic. So now topic is what? Freedom check mqtt. Okay, as I told you, again we need to save it. As I told you, you can mention any topic name. Okay, remember one thing, the topic name need to be same on publisher side, also on our subscriber side. So the esp8266 is basically our subscriber. So what is the topic? Freedom Tech mqtt. That's it. Then it will wait for the message, then it will check the message, then it will disconnect. And while true loop, and we need to call our client function. That's it. Now simply we are ready and we are going to run our subscriber. So simply run the code. We are ready. Now I am going to send the message from our Raspberry Pi 4. So we need to open first on.py, just run the code, and I can see here my esp8266 onboard LED on, and if we go on Tony editor, as you can see, the message is what? LED on. It means we have successfully sent the message from our Raspberry Pi 4 to our esp8266. Now again we need to go on our Raspberry Pi 4. Now the off.py, now the onboard LED is off, and as you can see we have the message LED off. Okay friends, so this is how you can send the message from Raspberry Pi 4 to esp8266 with the help of mqtt. Okay, so this is what our second part, where we configure the subscriber and the publisher. Okay, on next video, which is the final video, where we are going to detect the object, and then when the object, or we can say when the person detected by the TensorFlow Lite, it will send a message on our esp8266. Okay, so we are going to see all these things in our last video. Okay, till then, thank you, take care, and bye bye.